Yes. So last week we had the Odyssey Women's Sprint, and it was a global virtual event where different researchers and developers and scientists came together to either develop new applications or learn how to use the Odyssey portal, and also just encouraging each other when using these tools. Yeah, so for my section, we were trying to visualize the impacts of climate change, and we decided to investigate Mount Kilimanjaro's ice caps. So since the glaciers are very sensitive to climate change and they're easy to observe, so we tried to get the time series satellite images over a couple of years. So yeah, time series images, so that you can compare how it looks, and we wanted to know if Earth observation data can help in tracking the changes through time. So this is a photo of Mount Kilimanjaro. It's very beautiful. Yeah. So we had to ask ourselves a couple of questions, like, can you use digital Earth maps to visualize the reduction in Kilimanjaro ice caps through time? And this is an example of one of the images. This is 2019, the snow caps in 2019. This is in 1986. So that's when we realized we could actually do it. So we experienced a couple of challenges while developing our story maps. So the first issue was cloud cover, and because it always blocks the mountain peaks. So we decided to find out the seasons in Tanzania, and we realized that the dry season is in June to October. So that's when we focused, when selecting the images, that's the period we were targeting, so that we get cloud cover-free images. And another challenge is Sentinel-2 has cloudless annual composites, geomag composites, but it doesn't, it's only for a short period of time. So we couldn't use it throughout the analysis. Yeah. So another challenge we faced was distinguishing the difference between cloud and snow. So we decided to use the false color. And that's why it appears blue and cloud white. So we're able to distinguish the two. And for seasonal variation, because definitely the amount of snow cover changes over the year because of difference in temperature. So we wanted to know if it's truly reducing or if it's just a change in season. Yeah. Then we used Landsat 5, 7, and 8 data to get the time series data spanning for multiple years, so that you can capture the long-term trends. So this is in 2020. You can see that the snow cover is a little, the snow cap cover is a little. Then this is 2019, 2018, it's a bit more. 2017, 2015. I think you can see the change as I change the images. So this is in 1999. It was a lot. 1996. So you can see the difference between the clouds and the snow. Mm-hmm. So we concluded that despite the seasonal variation, there's a reduction in snow cover areas, and it was visible throughout the images between 1986 and today. You can see the differences. I think this is the same time. Yeah. Then we thought it was cool to view a 3D image of the mountain, and we could also still see the difference. Like this is 1984 and this is in 2021. Yeah, it shows the difference quite well. Yes. So after that, so for the next step, we wanted to try to create a seasonal cloud-free composites for the different seasons, and also to compare it with existing climate data. But the climate portal for Tanzania wasn't working. So I would like to request if any one of you could advise me on how to get the data. Then you want to create animation to visualize the snow area. Then we'll try to calculate the total area of the snow cover. So you may choose the sandbox, maybe. I don't know how we'll go about it. I don't know if water extent we could use that. I'm not sure. So you could assist me with that. Then that's I've already said that. So we wanted to try and create histograms for the snow cover by elevation, and then see how it changes over time. And then we determine the variation in the area reduction by elevation. Then we see if we can use the time series analysis as a tool to predict future rate of retreat. Yeah. So for communication, maybe we could write a blog or include the analysis in the larger communication piece on how the impact of climate change is being felt across Africa. Thank you very much.
Thank you, Eileen, for this great presentation. I wish if it's possible, you could share with us, even if it's a PDF version, so that we can actually grasp and see that one of our own actually is doing something with the DA Africa maps, which is an easy way to start using the data before you just go to the sandbox. Thank you so much. And thank you very much for participating in the ODC sprint. Any questions for Eileen?
I had a quick question, which is,
Yes.
but you used both annual composites and I guess I kind of missed it in the presentation. You were using annual composites and seasonal composites, or just or you said you decided to look at just the dry season, but you were also looking at products on the portal, on the Explore portal as well. Is that correct?
Yes, but we just decided to use representative images, not annual. Yeah.
Okay.
Yeah.
Was it difficult to find the representative images? How did you go about finding them?
Because in the website you can see which month has the data is available for which month. So that's the ones we were selecting.
I see.
Yeah.
Okay.
Yeah.
Very neat. Those are some really nice pictures.
Thank you. Thank you. I agree. So I have a question.
Yes.
So for the, how can you find the extent of the snow cover? How can you calculate it? Will it be okay to use the water extent notebook?
You would probably want to change the index you calculate. There are snow cover indices. that you can use. Off the top of my head, actually, let me bring up the. I would use something. I think there might actually already be something in the calculate indices tools. Let's see, the Africa tools, band indices, and going down the list here. So yeah, the normalized difference snow index is there. That's probably what I would try first, and then you would probably set a threshold. Most of those indices are designed to, kind of center around a value to separate into two different like snow and not snow, or water and not water. And you would set a threshold, and then you could, from that, you could count how many pixels are above that threshold, basically. And if you know how big a pixel is, and you know how many pixels there are, then you can find the area of snow cover. Now, that gets a little more complicated both with the water and the snow cover, when you, because you don't know how deep the snow is, right? Like, or how deep the water is. But snow's a little bit easier because it usually, even though it may be spread out, it's usually not that deep. It's still on the, maybe a couple, maybe a few meters at most, right? And so, although these are probably quite large snow deposits as well, so I don't know how depth of the snow would change. But that's the approach I would take. There's another problem, which is that clouds also end up kind of messing with this calculation, because if you mask them out, then you have to determine, I guess if you were choosing individual clear photos, though, then you wouldn't have this problem. But if you were using some sort of longer time series where you were including masked out clouds, then you'd have to determine what you do with the area underneath the cloud. This turns out to be a more problem with the water extent notebook, right? Where you have a very large lake, and there may be some clouds in the lake, and that will kind of make it seem like there's maybe less water extent. But maybe for a smaller area, or snow cover or something like that, it might not be as big a problem.
Because it was one of the main problem that I thought would be with face. Yeah, thank you.
Yeah, clouds ruin everything. In remote sensing, they ruin all our fun.
Yeah.
Thank you so much, Eileen. I've posted a paper on that topic.
Oh, thank you.
Journal
Thank
from
you very
South
much.
Africa could be of interest in
Thank
the near
you.
future. And also, is it possible for you to share the PDF of the presentation on the chat, please? There's some people really want to see, asking me behind the scenes, where is this presentation?
Okay. I'll put it. Can I post it in the WhatsApp group? Because I haven't converted it to PDF yet.
Anything works, but Kelebogi has a question for you.
Oh, okay. Thank you. Yes.
Hi, Eileen. Yes, I want to know if you get any flow, like when the snow is melting. I don't know. Is there any flow that you can estimate? Maybe how much is the volume of that water that is lost due to climate change or due to the reduction in snow?
Oh, that's very interesting. I can try and find out.
That's some additional work for Eileen, and also Eileen has a background in water engineering. Yeah, so this will be a nice possible topic for you, for a PhD moving forward. And Kelebogi has a lot of experience on the same as well. She could be a potential collaborator, so you could connect.
Oh.
I could
thank you.
I could put her email here, then you can start discussing.
Thank you.
Anyone else? Yes, Brian.
Yeah, I had one more question, which is, what prompted you to look at Kilimanjaro? Was there Was that it is that you were expecting it to be a good indicator of climate change, or some other reason?
Yeah, we thought it should be a good indicator. Yeah, so we thought let's just try it and see what you could get. Yeah.
Mhm. And do you think on further investigation, would you expect? So it seems like there was significant yearly variation. Does a lot of that come from differences in precipitation, or is it some other differences, do you suspect?
That's why we wanted to compare with the climate data that I wasn't able to get. So as of now, I'm not sure, but I'll still look for the data, then I'll know if it's just climate variation or it's more, like there are more reasons.
Right. Yeah, and I guess then plotting something over many years, you could see the yearly cycles, and then see if there was a downward or an upward trend overall. So, very interesting.
Thank you so much. We have a presentation by Bako.
Yes.
Yes, sir. Please, the screen is yours.
Yeah. Okay. Thank you so much. I want to share what we did about the lecture. Can you see my screen?
Yes, Bako. Wonderful.
Thank you so much. So, hello everyone. So, just what we want to share from AgriMet is our experience in the use of the sandbox to have some information about the natural resources. And today we want to talk about the Lac Tchad. Lac Tchad is a very, very important place in West Africa. So we want to compare 2 years, 2016 and 2019, with using sandbox, as I said. So from our perspective, we saw that in sandbox we have a thank you for those who are helping us to have all those scripts available in sandbox. And what we did is to choose one of them, to adapt it according to our interest, and to show you exactly what we receive in terms of output. So the Lac Tchad is not moving. Okay, so this is the Lac Tchad. So you have about Niger, Chad, Nigeria, Cameroon, about 4 countries who are interested in Lac Tchad. So this is you can see the position of Lac Tchad. I'm so sorry, I don't know if I have to use my mouse or the keyboard to move. Oh, yeah. Okay. So what we did is first of all, after loading the package, all what is needed to run the script is to define the area of interest by choosing the minimum and the maximum in terms of latitude and longitude. So you see what we define as area of interest, and we choose the 2 years, the starting years 2016 and 2019. We have one script allowing us to load and view Landsat data and the WOFS product. We made the calculation of area per pixel and the extent of water. This is the monthly time series that was plotted, and what we can highlight here is the maximum extent that we have. We receive them in between December, January, and February per year. Each year you have it here. Perhaps what will be good for us to do is you see the case of 2019. because this value is wrong. This one is wrong. It's not not possible to get the minimum like this here. We have to see this. Perhaps Edouard and Brian, you have to help us to perform the plotting of the time series, because what we have in 2019 is not the reality. So this is the minimum and the maximum in terms of pixels in the latitude. This is the Landsat water classified pixel for the 2 dates, 2016 and 2019. We have the animation of water extent, but I have it in the script. I can show it after, but I just copied my screen and paste it here, so you have it. It's possible. But just what I want to say is, according to it's a big area and the memory limitation. So the resolution we choose the 200 as a resolution instead of 30 or 100 meters. So if not, it will be so difficult to have this animation. So we compare the two periods we have with the WOF product. And you see here in 2016, if you compare it to 2019, you see we have the maximum of water extent in 2019. I choose those 2 years because 2016 is a little dry, and 2019 is we receive a very good rainfall in the area. So you can see the difference by comparing the two dates. So this is what we can receive from satellite Landsat data. And now we have the change for the 2 years, and you have the map here giving the water to water, we have the percentage. Water to no water, we have the percentage, and no water to water, and no water to no water. So you see, this is the map that we receive, and for the decision makers, this is the final product that is interested for them, and I think we can share it with them. So this is what I want to share with you by using Sandbox. We have Sandbox, we have the WOFs, we have all the material available in Digital Earth Africa, but we choose especially the WOF to see how to conduct this kind of study. Thank you so much for your attention. Over.
Merci beaucoup, Bako, pour la présentation. C'est a good, very good work from us. Congratulations for being champion and working closely with Edward to deliver this use case. I believe there are people who might have a question for Bako. This is your time.
Okay. I saw
Michael.
one question.
Oh, yeah.
Okay.
I had a question. What do you think happened in 2016? What do you think caused that area to dry?
Yeah, it's dry because this is the situation in this part of West Africa is there is a link between the rainfall and what is expected in the lake. If you have a very good rainfall, the water extent is it can reflect the situation.
Interesting. I guess what surprised me is that it seemed limited to kind of one area in the lake, which is kind of I don't know. It makes me want to investigate it a little bit more. It seems unusual, but maybe that's just the way the lake is.
Yeah. Okay. I think it's open. This is the beginning. I think we just saw how to use the Sandbox and from what we did, we saw that it's so easy to use it as a tool, and to get the final output that I share. And any improvement, any comments to allow us to perform or to enhance the output result, they are welcome.
I think somebody mentioned, was it you, Kenneth, that was mentioning MNDWI instead of NDWI? Or?
That's correct. And also, if we can overlay with the WAFs, we can be able to see
Okay.
something.
Yeah,
So
I
we
always.
the
Sorry, proceed.
DWI instead of NDWI.
Yes, yeah,
Okay.
it's possible to get something different, much better.
Okay. We will see. We'll use it.
MNDWI and NDWI are pretty similar, but I find that MNDWI, in my experience and with past analyses, has been more accurate. And then the other option is using WAFs, and there's WAFs is actually not a band math indices, but actually a kind of a decision tree that's been hand tuned, and it's designed for large extents of water, inland water. So it would be well suited to also identifying water in the different captures that you have. And I would also you said you had the animation. Is that handy, or is the
Yeah, I can show it to you.
You could send it in chat later as well. That would be interesting. I would like to see that as well.
Okay.
Another comment on the animation as well. Great work, by the way. You had mentioned that your animation was limited by the memory of the notebook. And I think Brian probably has a bit more experience with this, but I believe Dask can be used to supplement that. Is that?
It would be actually not quite, because that's a kind of a more complicated discussion. So the Dask can break things up into smaller chunks, but it may not. You may still end up using too much memory. Oh, that's very neat.
Yeah,
you can really see a lot of change in the north area.
Yeah, and I think with the DAX also, like during the animation session, it's just as Brian said, to use a lot of memory, because plotting it and computing it actually uses a lot of memory. So DAX doesn't actually help in plotting and visualize it, like the visualization. That's why DAX wasn't used at that point.
I see. Are there any recommendations on how we might optimize a higher resolution time series animation with limited memory in this case?
I don't have any at the moment, and part of it is that also eventually it all kind of has to actually be loaded into memory. And so there, you've asked kind of an edge case question, which is that one, Dask doesn't give you more memory; it allows you to break things down into smaller chunks. But one of the issues is that when you actually create the animation, you need to bring all of the different pieces of the animation into memory at once in order to make the GIF. So and write it to disk. So it's a little bit. Yes, it's a little bit constraining, unfortunately. But for these larger areas, I mean, I would love to see detailed areas up in the north of it. It seems like the water extent is increasing, and it also seems is that it's very the lake area is very green. Is that because there's a lot of vegetation around? Kind of. I see.
We have vegetation in the area.
Ah.
And sometimes under the vegetation we have water. Sometimes we have water, sometimes it's dry.
Right.
Yes.
Which complicates things even further, because the vegetation, if it is shallow water, if there's large extents of shallow water with lots of vegetation, that could also prevent that area from possibly being classified as water, thus kind of giving a false impression of the water extent. But interesting. Thank you for sharing.
Thank you very much, Bako. I wish to show you a small hint here, if you don't mind. This is one of the tools I normally borrow sometimes when I'm not sure about the weather patterns for this area. So WFP have been very instrumental in creating these patterns for rain anomaly and temperature and etc. And you can see the trend in 2016 was a little bit interesting, as you can see towards the end of the year. And also you can look for 2017, the trend is also similar, you can see. So pretty much for Chad, Niger, high rain season looks around August, September. Is this a little bit accurate for you, sir?
Yeah, I have in this link.
Yeah, so I had this example for a lake in Tanzania, and we had very similar story with Lake Chad, where the animation was showing very strange seasons around. Some lakes have experienced drought, and I think one of these was around this year. You can see December is a little bit dry, and pretty much December. So this data is pretty much from the ARA5 collection, which you can go way back to even 1990. And also I know Agreement does a lot of climate forecasting. So we can actually see that there's a linkage between that from November, things are just dry. And this could be a possibility of why we're having very funny explanation. Like I was trying to look at the WRF's summary, and I was looking at this for different years, 2015, 2016, 2017. So as a summary is that the blue is the dark water and these are the areas of variability. So this area has really had a lot of variabilities. So I think also, as we saw the presentation from Eileen Magera, is that also after the sandbox, we can also maximize the DE Africa Maps platform to do something like presenting a small story map, etc. If you work with Aziz to do something like this, once you have some time, it can be nice for sharing with some member states, something which is easy for them to open. For example, this page I've opened, I go here and share a link, and I've copied it and I've put it in the chat for you to just follow up on your side. So it looks like a very nice way of collaborating. Whenever you don't want to explore the whole data, you just explore on the maps and possibly even open on your tablet or laptop to present to our member states. And you know, our end users, some of them are politicians, some of them are donors. So if when they see the visualization, they'll be like, wow, now they'll get time to go and sit in your office and see the poster or see these analysis on Sandbox. So thank you very much, Bako. So these are just extra tools that I'll also put in the WhatsApp group for any future reference, the data visualization from the WFP to support the analysis.
Okay.
So I think anyone else has a question for Bako? Edward, do you have any update for Kilabugi? She had a similar study, and we could show something that she's developed. Edward, yes, sir.
Yeah, Ken, I'm here. So I think Dr. Kilabugi is actually working on the Okavango Delta with FANG, and they've actually made some improvements. So hopefully next week we will do a quick demo of what they've done so far and show it to the team. on the work they have been doing. And I hope Kelly Bugele can also give some update on from her part on the work so far also.
Please, Dr. Kilebugi. So I think she's connected.
Okay, so can next.
I didn't get. Sorry, I didn't get it. Was I supposed to comment or it's finished?
No, we wanted to hear how things are going with the support you're receiving from Digital Earth Africa, from Edward and everybody.
Oh yeah, no, it's going very well. Actually, we have very good preliminary results from the. It's like we are doing a multidisciplinary approach. Like we use a lot of data sets. Even now, I managed to get some river flow data set. So, but it's very good what we got so far, because we needed to also start from the headwaters, which is in Angola. So it's huge data sets, and handling them sometimes is difficult, but with the help of the team from Digital Earth Africa, we were able to actually analyze a lot of data that start from Angola, Namibia, and Botswana over the basin. And yeah, I still have to do my part, like maybe just sample small areas that I can handle with my computing capacity here, because it's a huge area. That's all for now.
Thank you so much. And this was the same example I wanted to show you from what we showed our previous colleague, that I have the Okavango area on DA maps, looking at the water observations from space. I can see how the area looks over time. Quite areas which are dry, different times, different episodes. And also the same, I wanted to see if I could see the same using this WFP data portal. So I'll just go to Botswana, and I remember there's a time you gave me a history of how things were looking. And for example, looking at the data for 2018, the whole country, I can actually go, and so it must be within Ngamiland commune. So you can actually see the rainy seasons are towards the early year and end of the year, and in the middle it's quite dry. Is that correct, Kilabugi?
Yes, that is the period that we initially wanted to focus on during the dry period of the, in terms of seasonal rainfall. But then we realized that the seasonal rainfall in Botswana is not actually influencing the flow, the river flow. The flow is coming from Angola, which is, I don't know how many kilometers from here, probably close to 2,000 kilometers. So, and the rainfall pattern there is more than what we get here, because in Angola, they can go to 1,500 millimeters in a year, whereas in Botswana, our maximum is around 500 millimeters in a year. So the dry season here is good in terms of showing the vegetation dynamics, but in terms of the river flow, we have to also take into consideration what is happening in Angola.
Thank you very much, Kilabugi. It looks like it's a question of understanding the dynamics of the hydrology patterns, which is very useful. Thank you so much, Kilabugi. I wish to welcome Edward. He had some tips on some ideas. Welcome, sir. Edward.
Thank you, Ken. Yeah, thank you, Ken. So as part of today's discussion, I wanted us to go through the map session and also talk about the new data set that we've actually added. That's the radar data sets from the map session. So I'll share my screen. Won't take much time. Okay, let me remove this. Okay. So this is actually the map interface that of the digital Earth Africa map, which has actually been improved, and the data are quite and very fast to load. So what we were just talking about was at the Kavango Delta. So normally the first thing that you normally do is just search the area of interest that you would like to work with. Then you click on it. Then the system will automatically zoom you to that particular area. The next thing is to go to the explore data. So today, for our data that we are going to use, the focus is actually going to be on the radar data. That's the Sentinel-1 data that we have on the platform. So once you click on the explore data, we have the annual data and we have the daily. For this particular example, I'll use the normalized radar backscatter for that particular area of interest. So once you click on it, then you can click on add to map. So for the area of interest, normally when you click on add to map, the map won't load for the area of interest that you are going to see because this is daily images. So maybe the current image at the area that you are picking won't load. So how will you actually get the current image of the area that you are working with is to use the filter by location. So once you click on filter by location, this dialog will come up, select a point by clicking on the map. So once you click on any area of interest, the system will load that particular image for that particular area. The latest image for that particular area will be loaded onto the platform. So just as you are saying, this is actually the latest image which is being showed on the map. With the time slider, you can actually look through and see the years that is available for the radar. So you can see that from 2019 up to 2020, we have all these images. And once you click on it also, it will open the January to February. But another trick that you can use is you can put this time slider on the timeline and use this one, the available time chart. With the available time chart, once you click on it, a pop-up will show down here and we will let you know the data sets that are available for that particular area. So if you actually look at this data we have here, you notice that the data actually started from April. In April, you can actually zoom in using your scroll. So you can actually zoom in and notice that the radar data actually started from February. And for this particular area that we are zooming, these are the available data sets that we have. So at any point where you see this green symbol, that means it's a data that we captured. So you notice that in between August and September, there was no particular date around this particular area. So depending on the ones you like, when you click on it, that particular area will load up onto the map for you to see. You can zoom in using your mouse wheel to actually boils down to the days in which you have the data and the days in which you don't have the data. So this session can also actually help you to know the months and the dates we have for a particular data. Let me do another example using the Landsat imagery that we have. So you can use, let's go for the Landsat 5. So you can load the Landsat 5. Let's turn off because the radar surface reflectors is on top. Sorry, so the Landsat is on top. So you actually see the Landsat, but you can turn off the radar because that's not the one we are currently using. So with the Landsat also, we click on the filter by location, then you will select the area of interest. So the imagery for the Landsat will actually be open for us. So the latest image was 2010 for the Landsat 5. So when we click on the available time chart, you notice that it actually starts from 96 coming, but in between, you also have an empty data set available. So using this time chart to actually give you an idea of days that we have data sets and the days that we don't have data sets. So if you're going to do further analysis, you actually know where to put your focus on and use it for the data sets. So this was just one part of this map that I wanted to introduce today. definitely next week there will also be another session that we introduce also to you. Thank you. Over to you, Ken.
Thank you, Edward. Was it also possible on this interface that you can generate a small animation for presentation, like for a workshop?
Yes, so you can actually create a story map, which you can use it to, you can share it with the users that you have. So with the story, with using the story map, can I continue?
Yes, please.
Okay, so with the story map, based on the images that you want, you can actually use it. So let's try with what we have now. So I'm going to use, let me close this one. I'm going to use both the surface reflectance and the radar. So what you do is the first thing that you do is to click on the capture scene. Once you click on the capture scene, it will ask you for the title of the image. So we can just say Landsat 1. Then if you have, Landsat 5. So if you have additional data, additional information that you want to talk in relation to this particular area, you can type. So you can let this an example. This image was captured. This image was captured on 16 May 2010. And if you have an image, maybe you have a nice image to show the area, maybe if you have a picture, you can actually attach that picture to that particular area. So by using this particular site, and after that, you can save it. Then you can switch to the other surface, which is the radar. So once you click on the radar, wait for it to load up. Then after it has finished loading, you click on the capture scene again. Then you can type, so this is going to be the radar image. Then you can give an additional information. So maybe captured on 25th June 2021. And give another explanation to give anyone who's going to have access to it, to give him an idea of what is actually happening. So after that we've captured, the next thing you can just click on the share. A URL will be generated for you, whereby you can I will copy it and send it with you on the chat. Then whereby if anyone have access to it and it clicks on the play, it's actually going to load it for him. So this is going to be the Landsat 5. Then the next one will be the radar image. So I've just shared it with you in the chat. You can actually try it at your end, and you see that whatever I captured here, you can actually do the animation also here.
Thank you so much, Edward. This is very useful so that we can also recap from next week. Brian had a quick presentation. Brian, this is your time, sir.
Thank you. So I'll share my screen real quick. So I was actually going to present something else, but based on the two great presentations by both Bako and Eileen, I thought I would quickly mention that the ERA5 climate data is also accessible via the sandbox. So if you go over to the datasets folder and look for the climate data ERA5 AWS kind of notebook here. So the idea here is that you can pull from AWS. They host a very large data set of basically weather forecasts and short to medium range weather forecasts. And so you can look at the precipitation, the wind, and the wind is actually in a 2-vector component. And there's actually a tool to actually extract its cardinal direction from that. And then there's also a lot of temperature at 2 meters altitude from the surface. So there's surface temperature as well. And then one thing that I thought would be kind of particularly interesting, I don't know the actual resolution, but we also have snow density and snow depth. And then there's also air pressure as well, and total solar radiation. And there's some other categories for waves, and there's actually just a whole there's even more than this, but these are some of the kind of highlights. And I think particularly looking at climate change, the precipitation and the temperature, both for the water extent and the snow extent, would be of real interest to see, to kind of characterize the different years and how they affected those extents. So to run this, you can just kind of run through this notebook. It's using from the tools package in DE Africa tools. There's actually a load ERA5 script here that it's using, and it's loading it directly from the Amazon Web Services cloud. And we define a latitude and longitude and a time, just as if we're loading data from the data cube. But in order to look at to load up data for different parameters, we just changed this var here, and it will go through and actually take the daily accumulation, daily total precipitation, which is interesting, and we can graph that kind of nicely. And then we might also want to look at the minimum and maximum air temperatures, for example. These are all the examples that are just in the notebook that is already on the data cube. I'm quickly going through this in the interest of time, just to kind of give you an idea of what you can do. So air temperature, and you can see this is actually quite high resolution temporally, and it's being resampled to 1 day, so it's even higher temporal resolution than just a day. Especially so if you were really trying to capture kind of outlier events or something like that. I'm not really sure what you would be trying to do, but that, and then we can do this over much longer periods of time, and over quite large extents as well. So this is actually just kind of showing, to get wind direction, you use Pythagorean theorem. And then here we are just looking at the air temperature over the whole continent as well. So yeah, I think it's quite a useful tool, because many of the different things we're monitoring are heavily influenced by the climate and the weather as well. As a side note, what I was originally going to talk about was kind of the classification notebooks and some of the tips and tricks with getting your data into the notebook. I think just, since we only have a few minutes left in the meeting, I'll kind of abridge this quite severely, but let's see, where is stop share, start share. So I kind of wanted to update. Tim spoke about the Prosopis, the invasive species Prosopis, a while back, and we've been working with him to kind of broaden the extent and update the extent of Prosopis classification around Lake Baringo. And we're trying to create a classifier that can run on the sandbox, so we're kind of duplicating his published work and extending it some. And the idea here is that he was kind enough to provide some data for us. And those are the points I have here graphed in blue that are in the southern portion. And then I was actually able to use the Collect Earth tool to actually create a random set of points around the lake that I was then able to go in to classify. And one of the things you might run into when using the data, the default data notebooks, is actually a little bit of data wrangling and getting everything into the right format. And so I would say the biggest tip is, whenever you have data, QGIS is a great tool to kind of both inspect and to really validate the data and make sure it's all in the same format. And so here I have I have one that was originally in a shape file and another one that was originally in a CSV. And so I was able to go through the delimited text here, and I can select a geometry field from the text. So the idea here is that I can select from downloads this, open, and so then I can, if there's custom separators or whatever, I know that there's a point here, and the point is in the sample geometry field, and then I can, when I go ahead and add that, it shows up, and then I can also load in the shapefile even just by dragging and dropping. And then I would say the biggest thing here is that then you can go to basically export save features as, and you can change this to GeoJSON, which is actually quite easy to manipulate both in text, and you can combine these different data sets. And that's what I've done here in the notebook in my work with Tim. So going back to the going back here, I was able to get it into the format that this notebook accepts. And so I have my Prosopis data, and the idea is that I have class 0 for negative results, and then I have class 1 for things classified as Prosopis. And going through QGIS, it's quite easy to get your results in that format, and you could actually just use the default notebook to your advantage. And I think that's the main tip I would take away from that. And I think I'm out of time looking at the clock at 7 o'clock my time. So I'll turn it back to Ken.
Thank you very much, Brian. You've actually left us hanging. One question is this notebook you're actually saying, is it possible you can paste it here on the group on the WhatsApp for guys to follow? That's
the thing, is that I haven't changed this notebook at all. This is the notebook that's in the real world examples, scalable machine learning, and this is the first step in which is the extracting the data. And I think it's I think one of the kind of daunting parts to this is usually taking your data from different places. And so one of the places I took my data was the Collect Earth project, and I went through and classified a bunch of plot. Anyways, it seems to have an error right now, but I added a bunch of data points here, and so using QGIS is an invaluable tool, I think, to kind of get that. And as long as you get it into, if you have two different classes, you can use the notebook as is, and you create a class field that, with either a 1 or a 0 in it, and you can use the default notebook.
Thank you very much, Brian. I'll actually even send the link to the guys on the GitHub for them to look further. Thank you so much. So any question for any of the presenters, or if you want a different topic to be presented next week?